This video is about permutation matrices. So a permutation matrix. Now, permutation means changing the arrangement, but in matrices, it means changing the position of rows or columns. So a permutation matrix is always square and only includes zeros and ones, which means it's binary. So it's a square binary matrix. Now, importantly here, which makes it more specific than other square binary matrices, is that each row and column can only have 1, 1. So for instance, this is a 2 by 2 permutation matrix. We know it's permutation matrix because it's square, 2 by 2. It's binary, it only includes zeros and ones, and each column and each row only has 1, 1 in it. This is the same. This is a 3 by 3 permutation matrix. It's square, it's binary, and each row has a 1, each column has a 1. So a permutation matrix is something we multiply by another matrix to change the position of the rows in that matrix or change the position in the columns. You've either got to do rows or columns. And how we do rows or columns depends on whether we pre-multiply or post-multiply. So if we pre-multiply by the permutation matrix, it's a row permutation. So see here, this is a permutation matrix. It's multiplying before this matrix, so it's going to change the position of the rows. And if we have a look here, this top row, row 1, 12, 42, 27, has become row 3. We're pre-multiplying, so it's a row permutation. If we post-multiply, which means multiply after the matrix, so like this one, this permutation matrix is multiplying after this matrix, it's going to change the position of the columns. So 12, 56, 34, column 1, becomes 12, 56, 34, column 2. Now, in order to create the change, we can actually just multiply them. So if we go to the calculator here, this is this one here, and we can just multiply them on the calculator, and that will get the new one, which is here. So in order to work out how it's going to change it, we can just multiply them, and that will let us know what's changed. So we can see row 1 has become row 3, row 2 has become row 1, and row 3 has become row 2. And the same thing can happen for a column permutation. So if we put that one there, and get rid of that little dot, then we can do the other one, which is this one, and that's shown that column 1, 12, 56, 34 has become column 2 has become column 3, and column 3 has become column 1. Now the position of the ones dictates which row goes where or which column goes where, and we can use that fact as a shortcut. So if we're wanting to quickly determine which row goes where or which column moves where, we can use this shortcut. So the position of the ones dictate where the rows and columns will move to. If it is a row permutation, look at the columns first, and if it is a column permutation, look at the rows first. Now that's a little bit confusing, but I'll show you what I mean. So if we're doing this one, so we're doing a row permutation, then we have to consider the column position first. So looking at this one, looking at column 1, we say row 1 will go to row 3 because that's where the 1's positioned. So we're doing a row permutation, so we look at the columns first. So row 1 has gone to row 3, and that's correct. Row 1 has gone to row 3. Row 2 has gone to row 1 because that's the position of the 1. It's in 2, column 2, row 1, so we know row 2 has gone to row 1, as it has. Row 3 has gone to row 2, and that's correct as well. If we're post-multiplying, we look at the rows first. So if it's a column permutation, we can look at the rows first. So we know this one is a column permutation because we're post-multiplying. So we can look at row 1. This indicates that column 1 moves to column 2, which is in fact what has happened. Column 2 has gone to column 3, yes, and column 3 has gone to column 1, which it has. So there's a shortcut there. Now an example of a question you might be given in an exam is one like this. So what I'd suggest you do is pause the video here and give this question a go, and then play the video to see what the answer is. So this one is pre-multiplying. It's the permutation matrix, which is this one. We know it's a permutation because it's square. It's a 5 by 5. It's binary. It only includes zeros and ones. And each row and each column each includes only one 1. So we know this is a permutation matrix, even though the question doesn't say that this is a permutation situation. We know that's what's happening. It's pre-multiplying, so we're going to be changing the position of the rows. Now, each letter is in its own row because this is a column matrix. So each letter is its own row. So what we need to determine is which letter is moving where. Now, there's a few different ways you can do this. You could actually just do this on the calculator. You can actually put letters in the calculator and you can multiply it. And that is an absolutely fine way to do it. Or we could use the shortcut. So the shortcut indicates or lets us know which row would move where. So I'm looking at these possible solutions, and I'm looking at, let's look at this fourth row. This fourth row has every letter different. So that's a good one to test. Whether if we tested row 1, it's only L's and P's, it wouldn't really eliminate any. Or all of them. So we want to look at row 4. Which row moves to row 4? Which one becomes row 4? So because we're pre-multiplying, it's a row permutation, we're going to look at columns first. So column 1 goes to row 3, row 1 goes to row 3, row 2 goes to row 4. So that's important. Row 2 goes to row 4. Row 2 is this E. So E will become the fourth row. So it must, in fact, be D as the answer. We can test all of those. Row 1 goes to row 3, so the L should be in row 3, yes. Row 2 goes to row 4, so E should be in the fourth place, yes. Row 3 goes to row 2, so A should be the second place, yes. Row 4 goes to row 1, P first, yes. And row 5 stays row 5, yes. So the answer is D. So that's permutation matrices. Again, this is in the summary. And make sure you understand that you can just multiply them. The pre-multiplying, a row permutation, post-multiplying, a column permutation, and there is that shortcut.